So I'm going to be talking a little bit about Vital, not because I'm an expert in it, and not because we're adopting it, but just purely because it's a good example to use, as it's an example that's being adopted in countries like Australia and New Zealand, also in South Africa, and some of the European countries with regards to thresholds and how they can be used for precautionary allergen labelling. So it's only an example of what some others are doing, not necessarily what the UK might want to do in the future. I'm then going to talk a little bit about some of the challenges that we have regarding analytical techniques for food allergen analysis, and also some of the factors that we want to consider when we're testing food products for allergens. So I suppose before I get started, I'm just really kind of curious if there's any members of the audience who've actually trialed or had a look at Vital, gone online and looked at the calculator. So I was just wondering, don't be shy, I'm out here. I was wondering if there's a show of hands, maybe, of who's had a look at this. That's really interesting. So that's about kind of half the audience that have, maybe about half that haven't. So to give you a brief summary of Vital, Vital's looking at the action level concept for precautionary allergen labelling. So if you are below action level 1, you would not apply a precautionary allergen label. If your levels in your product, your thresholds, are above the action level 2, you would adopt a precautionary allergen label or a may contain statement. The action levels are based on the reference dose, but they're also taking into account the serving size or the portion size that's being consumed. So the reference dose is based on the clinical studies, and it's represented in milligrams of protein. So you've probably seen in the previous presentations kind of example of the reference doses and then different portion sizes that have been applied to calculate what this actually means. So I thought from an analytical perspective it would be good to try and explain what that means from a kind of method provider's perspective. So above at the top of the table, I've just put the reference doses that I've obtained just by using the Vital calculator. And then what I've done is I've put in different potential portion sizes or serving sizes. So I've looked at 50 grams. 50 grams, to put it in perspective, is about the size of 2 cookies. That would be what some people would say would be a serving size. And then I've looked at 100 grams. That's more like about 4 cookies, which is probably more what I would eat. And then we've got 200 grams, which is about half a pack, which might be a really bad day at the office. So, you know, it's just to try when people are looking at these thresholds and they're thinking about how we can apply them, we really need to think about portion size because different people eat differently at different times. And certainly when it comes to nicer products, sweet products, we probably underestimate what we eat because we don't like to tell people that we eat like a packet of biscuits every now and then. So from an analytical perspective, this can be a bit challenging for the methods that we have available. So if I was to go back and look at 50 grams and look at the reference dose or the threshold that is then applied for the action level, this is again all in milligrams of protein. Most of the methods will be able to achieve this that we have currently available for the likes of ELISA. When we start moving on to the larger portion sizes, like for example 100 grams, you'll notice that the likes of egg may start to become a bit of a challenge for the analytical methods because the action level then would be 0.3 milligrams protein. And there are going to be very few methods that are commercially available that are going to kind of get down to that level. So moving on to 200 grams, then you're going to see additional allergens potentially becoming a bit challenging to analyze with the methods that are available. But the good news is that we're really not that far off. So if we have an understanding as method providers of what kind of acceptable portion, what portion sizes people are likely to eat, I think we could probably come down to meet these levels fairly rapidly. We just need a good dialogue between the food industry, method providers, patient groups to really kind of understand what we're wanting to look at. Another consideration, thinking to vital, certainly for me at least when I was looking at the calculator, is that we as a group sometimes think a lot about finished product testing, and we're very fixed on what is the result in the finished product. But vital is a concept that is actually, I think, wanting to take you all the way back. It's wanting you to take and look at your raw materials and your processes from start to finish. And that's really important because when you're looking at the calculator, it's going to ask you, if you're going through the process, what's the level of allergen cross-contact in raw materials? And then also, what's the potential allergen cross-contact through carryover from product, say from an allergen-containing line to one that doesn't? And actually, from an analytical perspective, you may not need to do testing at that level. You might have raw materials suppliers who are providing you analytical results based on the materials that you're receiving. They could be inputted into a calculator. And when you look at the carryover product, that might be able to be theoretically determined. So if you know that you have a mixer and that several kilograms of that product may go into the next batch, and that's as good as you can clean down to, then you should have an idea of what's in the previous product recipe and then know how much potential allergen crossover there could be from that batch, from that particular area. Another aspect would be to consider is concentration. So are there any processes in the actual facility? Are you baking a product where you're losing moisture? Because that would potentially concentrate any of the material, the protein present in that product. So these are all factors that I think are worth considering when looking at these systems like Vital, because they're not focused on finished product testing. They want you to actually risk assess the whole process. And there are some areas where thresholds are not going to be appropriate. There's a very good guideline from Camden Guideline 71, which talks about the role of allergen thresholds. And I've just really summarized some of their statements here on where thresholds are not going to be applicable. So this would be where you actually have the allergen contained in the food. That's quite an obvious one. The other areas were where the food is targeted towards infant consumption, because obviously we have good data with regards to the adult population and children for some allergens, but not for infants. Also, where the food is being directly targeted to people who are allergic, so free from claims. So in this guideline, that would be considered an area where thresholds for precautionary allergy labelling would not apply because of the risk. And then also, if good manufacturing practice hasn't been optimised, so if you haven't put into place the risk assessment tools, there's no point testing. You won't get any meaningful information, and also thresholds wouldn't be applicable. The other area is where documented risk assessments indicates that the risk of allergen cross-contamination is remote. Because if the allergen cross-contact risk is remote, then you shouldn't need to apply a precautionary allergen label. So now moving more into the analytical side, or some of the challenges that we have. If I was to think of all the different methods that we have available, many have been available historically for a number of years and predate some of the discussions that we've had with regards to protein or total food. So we have a variety of methods out there for allergen analysis, and they are reporting as different units. So some are reporting as protein, others are reporting as specific proteins, for example, casein in milk, and others will report as total food. But if we're moving towards allergen thresholds, we're going to have to look at everything being available on a protein scale. Now, that sounds like a challenge, but actually, from my perspective, I think we could do that fairly easily So we have databases available. Different databases are used in different countries. So in the US, there's a USDA database. There's also McCants and Widdowson, which gives a good value of the protein content of standard foods. So if I was to give you an example of some information that we've put together, we have put protein conversions available for the major allergens for the test kits that we're providing. And I think that that's a manageable way of dealing with that situation, to be able to report as milligrams per kilogram protein. So the other thing that we need to consider is how we can compare methodologies. So at the moment, the kind of primary methodologies we have for food allergen analysis would be the ELISA methods. There are also PCR methods. They're indirect, but they can be useful for some of the tree nuts, for example, where there aren't ELISA methods available. We also have LCMS as an up-and-coming method. And in the future, who knows, we may have new methods that become available for allergen analysis. They have different targets. So predominantly with ELISA, we are looking for the likes of protein. For PCR, we're going to be looking for DNA. And the methods are using different calibrators, so they may be standards that are prepared from the allergenic food. They could be standards from specific protein fractions. And really what we need is a kind of agreed reference point. I'm carefully not saying certified reference material or reference material right now, because that's another challenge, but we do need an agreed reference point, a well-characterized material for the methods as a pointer in the sand, a line in the sand, so that we know where we are. And this needs to be available for each of the allergens. Now, one of the challenges is that there's a lot of variability with the allergens that we're looking to detect. So we've been discussing, as an analytical community, certified reference materials for allergens for a long time. And I think we're still going to be discussing it for many years in the future. What I think we may be moving closer to are reference materials that the analytical community can agree on, where we have the allergen well characterized, so we know what the protein content is that's being used to incur a particular material, such as a cookie, for example. And that we have a characterized protein profile of the milk that's going into that material. And this is the line in the sand that methods could use to try and compare results and see how we're performing. But that will be specific to that incurred matrix. So, for example, a cookie. And we don't have these widely available yet for all the different allergens, but there are a number of groups that are working on it. So I think that's going to be quicker than certified reference materials. And I think it will certainly help us moving forward. So now I really just want to talk briefly about some of the key factors that we need to consider when we're looking at testing. So just to touch on each of these, some of the things we need to think about are what the physical nature is of the allergen that we're wanting to test. You need to think about sampling. That's a huge area in itself. Effective processing on the food allergen, and also any potential matrix effects. So anyway, the physical nature of the food allergen, what we're dealing with here are naturally grown food commodities. So for some materials, you might find there's not a lot of variability, like milk powder from New Zealand. It's quite similar to milk powder from the EU and from America. There will be some differences, but protein content is quite consistent. That is quite different when you look at other allergens. Sesame seeds, bit of a challenge there. Depending on the agronomic conditions, you can have protein contents of 18% to 22, 23%, depending on the variety and where it's been grown. Now, that doesn't sound like a lot, but the difference with 1% is 10,000 parts per million. So that can have an impact when we're thinking about our analytical methods and how we're actually measuring the protein or the allergen available. In addition to this, although I haven't put it on the slide, we also have to think of the likes of cross-reactivity. So some proteins are very homologous to each other, so there will be, for some methods, challenges. So for ELISA methods with mustard, then other brassica species like rapeseed will react. So these are things that need to be considered when you're looking at thresholds and analysing food allergens in your products. Are the allergens present as particulates, or are they readily dispersible? So is it sesame flour or is it sesame seed? This will have a big impact on detection. If you take sesame seeds and put that on an ELISA or on a surface and take it away and then carry out analysis, you're probably not going to pick up sesame because all the protein is contained in the seed hull. It's only when you crack that open and it's available that it's going to be detectable by the method. How much allergen is in the product recipe? Is it diluted out, for example, depending on what ingredients you're using, like seasoning mixes? Also, what's the protein content for different types of allergen ingredients? So I've given an example here of milk. We've got liquid milk, about 3%, 3.2% protein. Skim milk powder, 35.1% protein. We've got yogurts and we've got cheeses. Cheeses will vary depending on what kind it is, maybe 18 to 30% protein. But on top of that with cheese, we also have to think about proteolysis. So as cheeses ripen and age, and there's a very good paper by Catherine Evans in collaboration with Steve Taylor and Joe Beaumart at FARP, the proteolysis will impact detection. So you may be able to detect cheese when it's 6 months old, a year old, but if it's 24 months old and it's been ripened for a long time, that ripening effect has an impact on allergen analysis. So validation is key. I just thought I would show you the importance of the impact of the format of the allergen that you're testing to try and give you an understanding of the challenges we're facing for the analytical methods. So this is an example of sensitivity curves from one of the devices that we manufacture. And what you'll see is that the sensitivity will vary depending on the process for the allergen. So if I look at something like the walnut, the kind of raw English and black varieties going down to 1 ppm detection, defatted, as you would expect, is also very sensitive because you've taken away a large portion of the fat which is interfering. But when you move on to the more processed, like the oil roasted, where you've had that direct heat, then that is going to damage and aggregate the proteins, so your detection with that method is going to be slightly higher. So this is something that just needs to be considered for analysis. And it's manageable. It just requires a bit of care and validation to really understand what the methods are detecting when you're using them. I can only briefly touch on sampling because it's such a huge area, but when we're thinking about sampling, just consider that the methods that we're using are detecting maybe suitable for analysing a gram or 5 grams. Some of them are 0.25 grams of the sample that you want to test. So if when you're sending that material to a lab, it's not representative, then the information that you're going to get back is not going to be helpful. I've put an example of a paper here which might be worth looking up. It discusses the challenges of homogeneity within raw materials. In this case, it was homogeneity for wheat grains in oats. And the challenge that is affected with that is that if you do not have a homogeneous material to start with, then this is going to be challenging from a sampling perspective and also from an analytical perspective when we're moving forward towards thresholds. Thinking about the effect of food processing on allergens, ELISA tests, for example, are based on antibody reactions. So we're looking for protein that is readily extractable and close to its natural state. And there are instances where that's not the case. So be aware for hydrolyzed proteins, hydrolyzed egg, hydrolyzed milk powders. These may not give you a typical response on ELISA assays. Fermented products and cultures can be challenging. Soya sauce, fermented for a couple of years, so the protein is degraded and is not going to be detectable by the allergen analytical methods. Processing aids, soy lecithin, for example, is polysaccharide. Should have been refined in such a way that the protein isn't detectable. Doesn't always happen if you test the lecithin itself. If the refining process is broken down, you can detect it sometimes. But by the time you've added a tiny amount into chocolate, then we're not going to be able to detect that. Enzyme proteases may interfere. Colored food additives and flavorings at concentrated levels, 100%, could also cause interference. And we also have to consider the effects of the food processing conditions on the allergen to be detected. So, for example, are you baking? Are you frying? Is it going through an extrusion process? What kind of impact is that going to have on the structure of the proteins that we're trying to detect? So, wherever possible when you're validating, it's good. We often send product samples away looking for negative results. But if we're validating, so we're considering you're not just looking for your negatives being negative. If you have the product that contains the allergen that's gone through the process in the factory, what you're also looking for is that the positives are positive with the methods that you're using. So if I'm to summarize now, the good news is that there are analytical methods available to cover the majority of allergens. There are some gaps. Celery and mollusks would be an example. And this is also a challenge for the clinical data there as well. We do also need to consider the portion size when we're looking at moving forward with sensitivity and methods. And I think we need to have a good dialogue here. We don't want the methods becoming far too sensitive, but they need to be in the range that's going to be useful moving forward with analytical thresholds. We're quite close for most of them, but some of them do need a bit of improvement. We also need to think about the reporting units, so we need to think about moving towards a protein scale, and the community needs to move forward with reference materials. And then just to finalise up, because every factory is different, every process is different, what would be really helpful is to think about ways that we can move forward for best practice for validation as well. Okay.
So, Pauline, thank you very much for that marvellous presentation. You've just confirmed how little I know. So, do we have one quick question for Pauline? Thank you.
Thank you. Great presentation. The one thing that I don't think you covered off at all in detail was cross-reactivity. And also one of the big issues we have, particularly around mustard, is the high level of cross-reactivity with the Brassicaceae family. Is there any light at the end of the tunnel in having something that would be a little bit more dependable? Because also that prevents a lot of claims being made, which otherwise would free up foods for people with that allergy.
Okay, so from an ELISA perspective, that is going to be extremely difficult because they're part of the same plant family. So they're all covered by the Brassica family, and the proteins are homologous on, I think it's the 11S. So we are probably not going to be able to eliminate that cross-reactivity because it's intrinsic to the antibodies that are being produced. However, what is worth bearing in mind, of thinking about mustard, I was at a conference a couple of years ago in Canada. Steve Taylor was there and Joe Beaumont were there, and there was a discussion similar that came up with regards to mustard because obviously there's a lot of rapeseed production in Canada. And one of the comments that came out was that actually there was a question mark or concern that if you have mustard allergy, that there may well be oilseed rape allergy as well. I think our challenge is that we aren't looking at the families, so even if there is a clinical cross-reactivity, we're only looking at mustard. So I'm not sure from an analytical perspective we can do much from an ELISA perspective for that one. Whether we need to think in the future, I don't know, about whether we're looking at the right thing. Are we looking at mustard or are we looking at Brassica to try and protect people? then I don't have the answer for that one. But I think it's an area that should be looked at.
Thank you. Okay. Claire has a question.
It's just a comment on this. First of all, there is a novel foods approval which allows people to use oilseed rape protein isolate as a food ingredient in the European Union. That has to be labelled, and actually I suspect in the fullness of time, when they go through iterations of tidying up the regulations, that actually that will be included on Annex 2, and that was certainly at a meeting where Santé said that. So you need to bear that in mind. I think the issues for discriminating, exactly as Pauline has said, and to be honest, what you're going to have to do, because the homology is 97%, it is going to be challenging for DNA and mass spectrometry methods, and you are probably going to need a combined approach. The regulations say the species, so you're going to have to measure the species. Whatever is practical from a point of view of the analytical methodology, and it is a challenge for the commingling all the way down the supply chain. So I think that's something that we'll need a combined approach.
Thank you. Okay. Pauline, thank you very much indeed.